Hi everyone. The goal of this video is to make you understand how quantum computer works in a very niche level without lot of maths, without lot of chunky physics or anything like that. The goal will be to very simple so that you understand how quantum computer work and it increases your interest about learning it. So before jumping into how quantum computer work, I want you to give a very niche example and understand what deduction is. And we're going to understand through this experiment that happened in Tokyo, right? So basically, there was a mold, slime mold, uh, which helped the design the Tokyo's metro network, rail network, basically. So there will be multiple cities in Tokyo, and the goal was to find what is the efficient route, like path they can design, which will be like very like there will be less number of roads connectivity, and if one fails, other is okay, and everything is like in a such optimized way that like there is no extra time in traveling or something like this. So we use deduction. Basically, deduction is you have a bigger problem, you minimize it to into a simple problem, right? So that it could be solved through a very simple intelligence system, right? So meet pi serum polysphagium, whatever the name is. So this is a mold over here, and they have no brain and no central nervous system. It only works with like finding the most efficient way possible of collecting food and growing, right? This is the only thing it can go. So what we do with this is like we take out all the we see whatever the cities we have in Tokyo, like the Tokyo, like Shinjuku, Shibuya, Yokohama, whatever these places, and the same equidistance, like dummy representation of, we place this oat flakes like a food source. And once you place this food source in this petri dish or something like this, and then we put a mold in this to grow. So mold will what will this will do? It will start eating these flakes, like it will start spreading and it will try to start eat all the flakes with it. And the way it grows is it goes randomly. It search all the best possible option. Like if you see, try to create the network or try to search the food everywhere. And once he finds all the like these flakes, now it what is does try to minimize its routes, right? He'll see if there is a same place, if one of the route is going this longer distance and there is one more he is going, what he will do, he will cancel this one and he will just make this one stronger, like minimizing the least path, something like this. So same thing happens. First was the exploration where you explore in all direction. Then in pruning stage you decide okay which are the best one. Then you start eating the other part. And the end you find the equilibrium state where you find the correct path where they are in like the least distance possible. Not only that they did, they also made sure that there is a fault tolerance network. Like if one of the paths broken, still you can reach. Like if this path is broken, I still can reach this place to this place by going through this long route or something like this. So that network made sure, and also the total length of this infrastructure was minimized. So naturally, this way, this designed this rail system network. So you can see how we can have this bigger problem, a rail network, big geography thing, and we compressed to a petri dish, same like equidistance. So what we did, we represented the distances in kilometers to millimeters inside this, centimeters inside this petri dish. That is called reduction step, and then we solve using this simple organism. So this is one of the simple intelligence system we did, and this could be used for many optimization problem, logistic and chain optimization, traveling, salesman problem. Like we can convert a lot of problem into finding optimized place. Like you can think of a portfolio problem, right? You can think of a AI problem. They could also change into something like optimization problem. That is called deduction. Same way, the way you are watching this video or using the computer, uh, this is made from simple operation of like and NAND or a NOT gate. NAND gate is basically something like if you have any input, two input is 0 0, so it will has to produce one. If the other two input is 0 1, it has to produce 0 or something like this. So just simple intelligence steps. So all the things which you are running around this AI smart system, chat GPT, this all can be broken down into simple operation of zeros and one. And if you're able to solve this, become little intelligence to solve this thing, just some simple binary operation, you can build all the computer from there. Right? This is reduction step. Bigger problems chunked into a smaller problem where you have to decide if two inputs are zero, then what it should be output should be one. If there's one is zero and one, there should be zero, something like this. Is one and one, it should be zero or something like this. So if you deduce the problem in a such low level, you require very less intelligence and you can do a lot of work.